Right now, LED headlights dominate the market, and for good reason. They're bright, they're energy efficient, and they last tens of thousands of hours. And perhaps most importantly, they've been battle tested on millions of vehicles in real-world conditions. LED technology offers an ideal balance of cost, performance, and reliability. Automakers love them because they're flexible in design and meet strict safety and efficiency regulations. Consumers love them because they work. So before we talk about what's next, let's be clear. LED is still the standard and it's still evolving. Matrix LEDs, adaptive beams, pixel control, these are all advancements within the LED family, not replacements. Within the world of LED, tech is evolving fast. 3 cutting-edge technologies, laser, OLED, and micro-LED, are stepping into the spotlight. Each promises to redefine how we see and are seen on the road. The question is, how do they measure up to each other, and why are LEDs leading the way? Hi, I'm Samuel with Auxito, and today we're talking about the future, and it's never looked brighter. What made people use traditional LED light? The widely adopted traditional LED headlights began showing in automotive applications due to a combination of technological, economic, and design advantages over older lighting LED systems like halogen or HID. Now, LEDs are bright, not just see ahead bright, but clean, white, daylight-like illumination. That means better contrast, sharper road visibility, and faster driver reaction times, especially in poor weather or at night. LEDs deliver instant-on brightness and precise beam control. They're ideal for both low beam and high beam patterns, giving you more confidence on the road. LEDs are also more efficient compared to halogens or HIDs. They use a fraction of the energy while delivering more usable light. That's especially important for electric vehicles where energy savings directly translate to more driving range. Less energy draw also means less heat, which reduces strain on the electrical systems and other vehicle components. And since LEDs last up to 20,000 hours or more, and higher quality models last up to 50,000 or more, you won't be replacing bulbs every year like you might with halogens. In most systems, the LED headlamp system is designed to last the life of the car. Finally, LEDs have matured over the years. That means it's more cost-effective, mass-producible, and compatible with a wide range of vehicle designs. Because LED modules are compact and customizable, they give car designers flexibility. You get sleeker headlights, cool running lights, intricate shapes, and distinct lighting signatures without compromising performance. Even aftermarket LED upgrades are now widely available, with plug-and-play kits for most halogen sockets like the H11, the H4, or the 9005 bulbs. That puts LED lighting in reach for almost anyone. Now that we've set the stage to where we are, let's talk about where we might be going, starting with laser headlights. First introduced in production vehicles by BMW and Audi, laser lighting sounds like science fiction, but it's very real. The practical application comes from light visibility in the dark and rural areas using blue laser beam focused through phosphor to create an ultra-bright white light. Because the beam is extremely focused, it allows for highly controllable light shapes, selective dimming to avoid blinding other drivers, dynamic real-time beam patterns based on speed, steering angles, or oncoming traffic. Think Matrix LED tech, but with even finer resolution and control. Laser systems can be more efficient than traditional lighting when outputting extreme brightness. That's a big plus for electric vehicles, where conserving power can extend driving range. Laser modules can integrate with autonomous vehicle systems for projecting symbols or communication to pedestrians, augmented reality heads-up displays, road surface projection like warnings or arrows similar to some of BMW's future tech plans. Laser lights are also extremely compact, allowing more design freedom for automakers, but they aren't perfect. They're expensive. I mean thousands of dollars more expensive than standard or even performance LEDs. They also require complex cooling in order to function properly, and require advanced engineering to fix, recalibrate, or really do anything with them outside of initial installation, with more moving parts and points for failure. While laser headlights are considered future tech, they're already looked at with criticism, and may already be on the way out for a few reasons. U.S. Federal Motor Vehicle Safety Standard Rule 108 caps headlight intensity at 150,000 candela, compared to Europe's allowance of up to 430 candela. This regulation drastically reduces laser headlamp performance in the US, shrinking their potential range from nearly 600 meters to 250 meters, roughly equivalent to advanced LED systems. Matrix LED technology has caught up and is now offering comparable range and better adaptive light distribution. Since laser setups typically require Matrix LEDs anyway, the additional complexity no longer justifies the marginal benefits. Laser headlamps can also cost $7,000 to $8,000 per unit to replace at the dealer. They require precise control systems to avoid dazzling other drivers, making them very costly to manufacture and maintain. While lasers allow smaller modules, recent car models with and without laser systems use nearly identical housing designs, undercutting that aesthetic argument. BMW has also ended development of new models with laser lights favoring Matrix LED tech. Audi has also paused development, focusing on more scalable and adaptive lighting solutions. For now, luxury headlights are a luxury reserved for flagship models. The current models for these lights include the BMW 7, the i8, Audi R8, LMX, BMW X7, BMW 4 Series Grand Coupe, and the Audi Q8, and will probably be phased out in future models. Next is OLED, organic light emitting diodes. While OLEDs don't match LEDs or lasers in their sheer brightness, they offer something entirely different: design flexibility. Unlike traditional point source lights, OLEDs emit an even, diffuse glow across a flat surface. This makes them ideal for taillights and ambient lighting, where a sleek, futuristic aesthetic is just as important as function. OLEDs are paper-thin and bendable, giving designers the freedom to create curved or sculpted light shapes, animated lighting signatures, futuristic lighting themes with brand-defining patterns. Think science fiction-centered light trims with programmable animated lighting. Drivers can increase clarity when turning, backing up, or navigating challenging conditions. Audi once again is leading the charge, integrating OLED panels in rear lighting clusters that can even animate based on driver input. On top of that, they're tiny, great for concept cars and experimental designs. But there are some deal breakers that make this technology impractical. OLEDs cost thousands of dollars more per system. They demand advanced cooling, advanced calibration, and ongoing maintenance that makes DIY repairs or upgrades basically impossible. Additionally, when OLED is used in non-front lighting parts such as taillights and ambient lights, power consumption may slightly improve the overall energy efficiency of EVs, but it won't have a significant impact on main illumination or range. Models that have this lighting are the Audi A8 and the S8, the Hongi H9, the Audi Q5 SUV, the Bugatti Divo. Then there's micro-LED, the newest player in the space. Micro-LEDs combine the efficiency and brightness of traditional LEDs with pixel-level control similar to OLEDs. They're tiny, measured in microns tiny, but very powerful and incredibly durable, with the ability to custom tailor to any situation, like city, rural, snow, fog, or otherwise in a headlight application. Under the collaboration of the vehicle perception systems such as cameras, radars, AI decision-making systems, the micro-LED array can achieve functions such as projecting signs for pedestrian like passable or danger warning, and dynamic lighting guidance. These capabilities rely on the high-resolution characteristics of the micro-LED and the interaction with the intelligent hardware of the vehicle rather than the characteristics of the micro-LED light source itself. Micro-LEDs promise that kind of precision and more. They're still in the early stages for automotive use, as scaling is difficult with precise manufacturing and heating solutions are still in the early stages. But there is potential, especially as costs come down and manufacturing scales up. Models that incorporate micro-LED in some form are the Volkswagen Tiguan L Pro, the Volkswagen Touareg NIO ET9, and the Porsche Taycan. The future tech sounds awesome, but let's temper some expectations about next-gen lighting. There's a ton of problems that need to be addressed, and they're still far behind in pricing and practicality compared to LEDs. These lighting concepts are just that, concepts, or for those with very deep pockets. LEDs aren't going away anytime soon. LEDs will only become more prevalent. They remain the most practical and cost-efficient choice for most vehicles, balancing performance, longevity, and price. Don't expect them in the next Prius model anytime soon. If and when concepts like this go to mass market, LED will be leading the way for core performance and design, while these other lighting technologies will most likely be supporting very specific roles for your vehicle. Automotive lighting isn't just about visibility anymore, it's about precision, personality, and pushing boundaries. What do you think about emerging lighting tech? Do you think these will become mass adopted? Let us know in the comments down below. Also, if you need some LED accessories for your vehicle, we can hook that up in the link down below. Like and subscribe for more automotive content with Auxito, and thanks for watching.